You've seen a lot of plot types so far, but one type has been conspicuously absent. That's the pie plot. It's a wildly popular plot type, but we've been avoiding it for a good reason. Here's the bar plot of famous athletes by sport. If you convert the coordinate system for the plot from Cartesian coordinates, that is, standard x and y axes, to polar coordinates, you get a pie plot. A pie plot is just a bar plot, where the bar lengths are converted to angles. Unfortunately, this plot is much harder to interpret than the bar plot. For example, it's really hard to answer questions that were easy with the bar plot, like how many cricketers were there on the list? Data visualization research suggests that bar plots are almost always easier to interpret than pie plots. So the answer to the question of when should you use polar coordinates is that they're almost never a good idea. There is one exception, though it's fairly niche. If you have data that has some natural circularity to it, like the time of day or a direction, then polar coordinates can be acceptable. Here's a histogram of animal activity from the Panama camera trap dataset. You saw this as part of the pair plot in the previous chapter. It's a great plot with one problem. The activity from the nocturnal packer appears to be split in two, because the plot doesn't recognize that midnight on the left of the x-axis is the same as the midnight on the right of the x-axis. One possible fix is to convert the histograms to polar coordinates, forming a rose plot. This is slightly different to the pie plot because it's the x-axis that's converted to angles, and the bar heights still remain as lengths. Now if you look at the packer's activity distribution, it's clearer that it's one burst of activity lasting all night, rather than two separate bursts. Let's explore some circular plots. Let's take a look at problems with axes in plots. One thing that's fundamental to bar plots is that the length of each bar is proportional to whatever value it represents. In this infographic found on the wonderful subreddit, Data is Ugly, the 22.5% scored by Yang in the poll appears to be much larger than the 21% scored by Sanders, or Bernie, as he is affectionately referred to here. If we draw the bar plot correctly, you can see that the difference between the two poll scores is fairly small. I don't want to single out Yang specifically, but I would like to warn you to be cautious when interpreting plots on political posters. It isn't just politicians who play fast and loose with the rules of data visualization. This time we have a stacked bar plot from Data is Ugly about market share of phone operating systems. The problem with this is more subtle. Rather than making up bar lengths to look good on a poster, the values do match a real scale. The mistake is that the y-axis, containing market share, begins at 75% instead of 0. This makes it look like Android and iOS have similar market shares. If we draw the stacked bar plot correctly, we see that Android has a much larger share. Another common bad idea for plots is to use two y-axes. This is typically done when you want to plot two things on the y-axis with very different scales. Here you can see the United Nations dataset with length of schooling on the x-axis. The red points are related to life expectancy and linked to the y-axis on the left. The blue points link to the Human Development Index for the country and linked to the y-axis on the right. The two axes are needed here because the life expectancies are all between 50 and 90, but the Human Development Index is on a scale from 0 to 1. The problem is that by changing the right-hand y-axis, the interpretation of the plot changes completely. On the left, it looks like there's a strong correlation between life expectancy and Human Development Index, but on the right it looks like there's no correlation. You have to stare hard at the numbers on the axis to see what's going on. A much better solution is to admit that you're trying to plot two different things and keep them in separate panels, so it's clear to your audience that they're different metrics. Time to play with some axes. There are two basic measures of how good your data visualization is. The first measure is how many insights can the reader get from your plot. For far too many plots, the answer is 0. In this video, we'll look at some ways to avoid that situation. The second measure is how quickly the reader will get those insights. If your plot is being presented in a meeting, you might reasonably expect your audience to concentrate on your plot for 20 seconds. Often, you need to get your message across quickly. Chartjunk refers to anything in the plot that makes it harder for the reader to get insight into the data. We'll look at some common problems in the following slides. One term that's less well known is skeuomorphism. That means adding things that happen in the real world to virtual objects. For example, you could add shadows to bars in a bar plot. Here's an example from the BBC TV network, found on the Junk Charts blog. This probably ought to be a bar plot, but since the y-axis doesn't begin at 0, it suggests that maybe the BBC was aiming for a dot plot. In which case, is the height represented by the top of the head or the centre of the head? Using a picture of a man instead of a bar makes things harder to understand, not easier. This example was created by the Fox News TV channel and found by Media Matters for America. You can see some familiar problems with the bar plot, like the y-axis not including 0, distorting the relative heights of the bars. Also notice that the time periods have been arbitrarily limited to October to April, omitting what happened between May and September each year. Let's focus on the skeuomorphic elements of the plot. There's a shadow across the panel of the plot, which adds no value, but since it travels upwards and to the right, it gives a subconscious signal that numbers are increasing. The bars also have been given a slight depth to them. The 3D aspect makes it harder to accurately judge where they lie against the y-axis, so the bar heights have to be written in text to compensate. By stripping away all the junk, the data is easier to see. This plot was found on the Data is Ugly subreddit and has many problems. Try pausing the video and counting the issues you can find. Let's concentrate on the unnecessary use of 3D perspective. Bar plots are inherently two-dimensional. You have categories on one axis and a continuous variable on the other axis. By making bars three-dimensional, you don't provide additional information, but simply make it harder to judge the lengths of bars. A 2D bar plot is easier to read, although one category label is missing and the percentages don't add up to 100, so it's unclear what the y-axis represents. Here's another plot from Data is Ugly, showing seats in the German Federal Council. There are 16 states and several political parties. Parties typically have to enter into a power-sharing coalition to get seats in each state. Each political party has a colour associated with their brand. CDU is black, SPD is red, Grüne is green, and so on. Each state on the map, or slice of pie plot, has the colour of the party which won the most votes, and stripes coloured by the other parties sharing power. The problem is that the plot is just too ugly to look at, so no one can get any insights from it. In general, stripes or other forms of hatching should be avoided in plots, because they're just plain difficult to stare at. One Reddit user tried to improve the plot, as shown on the right. By removing the hatching, it's much nicer to look at the plot. Let's go to war on Chartjunk. Well done! You've seen a lot of data visualizations now. In Chapter 1, you learned that histograms are excellent for showing the distribution of a continuous variable, and that box plots can compactly show the distributions of lots of continuous variables. In Chapter 2, you saw that scatter plots can show the relationship between two continuous variables, and that line plots are great for showing trends over time. You also saw that bar plots show counts or proportions split by categories, and that dot plots will do the same, but allow for logarithmic scales and showing multiple metrics at once. In Chapter 3, you saw that using colours or multiple panels are often the best way to add a third dimension to your plot, since 3D plots are hard to interpret. You also learned that there are three types of colour scale: qualitative, sequential, and diverging. For cases where you need to analyse many variables at once, you saw three types of plots. Pair plots show relationships between each pair of variables. Correlation heat maps show related variables, and parallel coordinates plots show patterns across many variables. In Chapter 4, you learned that plots with polar coordinates are usually a bad idea, but they have niche uses when data is cyclical, like a time of day. You also learned that using dual axes is almost always misleading, and that minimalism is a good idea. You should eliminate anything from the plot that distracts from interpretations. If you're interested in learning more about data visualization, you can take courses on the R package ggplot2, which was used to create the plots in this course, or on business intelligence tools like Tableau, or Python packages like Matplotlib and Seaborn. Happy learning!